Okay. So I've become very fascinated the last 48 hours or so with ionized space engines, or ionized in space engine. The space engines ionize material in order. Anyways, the first thing that we need to look up is what is. Well, actually, is space a complete so the reason why I'm asking this question is because no one, I don't believe that for a fact. And what makes a vacuum? We're using the Earth as a measurement. When the Earth is a tiny data point in this huge uh, solar system that we have, right? And especially because we live in a radiating universe. The sun radiates. There's all sorts of stuff radiating, and we just don't have the tools to measure these finer details of life, and we're trying to establish them. Hence, gravitational waves and such. And gravity is the big G. But let's just avoid that topic right now. Uh, Space is black. Well, black hole is black, so we live in a black hole. There's no rules, or things are backwards. Why? We have this, quantum mechanics and stuff, but it doesn't go with Newtonian physics and all that crap, right? So, and the thing is, the black universe would be fed by a white hole, and a white universe would be uh, engulfed by a black hole. Essentially, light is information. Space is void of information. Even though no information is information. And the thing is that this new information is probably the reason why there's dark matter and dark energy and all that crap. So let's continue. So you got that? uh, yeah. So uh, what matter is suspended in space? Well, here we go. Gravity isn't just for keeping planets in their respective orbits, and just keep in mind, gravity is just a theory, and so we use the theory of gravity as the basis to establish claims, and that's just wrong because we don't say the theory of gravity, we just say gravity because it's so widely accepted, except for those of us with logic. So gravity isn't just for keeping planets in their respective orbits. It's a force that acts on all matter in the universe. That's the basis of Isaac Newton's theory of universal gravitation. The greater an object's mass, and the closer it is, the greater gravitational force on other objects around it. All the bodies in our solar system are affected by the gravitational pull of the sun. However, the sun is just one of hundreds of billions of stars in our galaxy, which in turn is one of more than 100 billion galaxies, all of which have gravitational pulls, all of which also move, by the way. For example, the sun completes one rotation around the center of the Milky Way every 230 million years or so. Einstein disagreed with Newton on gravity. His general theory of relativity stated that gravity isn't a force at all, but it's a curvature in space-time, or the fourth dimension. This means that objects like the Earth are actually traveling along a straight path. Because objects always seek the shortest distance between 2 points, but due to the curve of space-time, that straight path is spherical. There are some newer theories about gravity, but the important thing to note is that it's ultimately what holds everything together. Well, can I ionize space? Let me just get down to it. Can I ionize space? Oops. In summary, GCR are heavy, high-energy ions of elements that have had all their electrons stripped away as they journey through the galaxy at nearly the speed of light. They can cause atoms they pass through to ionize. They pass practically unimpeded through a typical spacecraft or the skin of an astronaut. And so what it comes down to is you have these things that are virtually massless. And anyways, they're because they're measurable. They're moving slower than the speed of light, but they have very little mass, and they're able to transmit information, pass through things, because things aren't solid. Outside the protective cocoon of Earth's atmosphere is a universe full of radiation. It's all around us. Say the word radiation to 3 different people, you probably get 3 different reactions. Your aunt might tell you that how radiation destroyed her cancer. Your neighbor might mention the duck and cover procedures of his day. And our comics loving friend will explain how gamma rays turn Bruce Banner into the Hulk. Radiation comes in many forms. Radiation is a form of energy that is emitted from the form of rays, electromagnetic waves, or particles. In some cases, radiation can be seen, visible light, or felt infrared radiation. While other forms like X-rays and gamma rays are not visible, it can only be observed with special equipment. Although radiation can have negative effects both on biological and mechanical mechanisms, it can also be carefully used to learn more about each of those systems. So, we have 3 particles trapped in the Earth. What is the density of space? On average, the density of matter in space is between 10 to the 11th million stars. That's 10 with 11 zeros on the end of it. Stars in the Milky Way is 0.1 neutral hydrogen atoms per cubic centimeter. And so we're able to ionize that, even though it's very scarce. It's space and there's plenty of it around. Ionized aircraft. Ion drive. You know those air ionizers? I've got one. But that's what it does, is it charges electrons and stuff, and So it creates a negative pressure. Well, due to different polarities of materials. It almost looked like right when it turns off, there's a peak in the energy, which is why it spikes. I don't know if here. So that's just launched. Now, not this clip, not this one. Now this one, watch. It raises. Boom. Just ever so slightly. And so, now I'll go to what is ionization? Ionization is the process by which an atom or molecule acquires a negative or positive charge by gaining or losing electrons, often in conjunction with other chemical changes. The resulting electrically charged atom or molecule is called an ion. Thank you, Google. Air ionization. The tallest objects in a storm don't always get struck by lightning. Lightning strike the ground at close distance to a tall object. The electric field causes surrounding air to become separated into positive ions and electrons. The air is ionized. Lightning ions. The 30-30 rule is an easy way to determine the threat of lightning in your area. 30 seconds. Count the 30 seconds between seeing lightning and hearing thunder. If this time is less than 30 seconds, lightning is a threat. Seek immediate shelter. What, 30 seconds count? That's a interesting little fact there. Alright, well, just doing some research. Take care, be safe, be kind, stay strong. I love y'all.